Hello everyone, my name is Angie Poggi, and in this video I'm going to introduce you to basic probability rules. Probability theory is the foundation of inferential statistics, which allow us to generate indicators of confidence or risk used for decision making. And so probability refers to the proportion of times an event is expected to occur in the long run. Probabilities are always numbered between 0 and 1, where 0 corresponds to never and 1 corresponds to always. If the probability is 0.5, then the event has the same probability of occurring and not occurring in the long run. Let's discuss some vocabulary words specific to probability. Population. In probability, population refers to the set of possible outcomes or valid values for a random variable. Event. Event is the subset of outcomes of interest for a random variable. For example, suppose a population has 5 members identified with the letters A through E. What is the probability of selecting member C at random? The result is X, which is the characteristic of interest, divided by N, the total number of possible outcomes. Therefore, X equals 1 because there's only one C, and N equals 5 because there are 5 members in the list. So the result is 1 over 5, or 0.2 or 20%. In this example, all 5 members have the same probability of being selected at random. If you remove one of the members, then the total number, or N, changes. This is what is called probability without replacement. If you remove member A from the group, what's the probability of selecting member C at random? Well, you got it. It will be 1, there's only one C, divided by 4, B, C, D, and E, which is 1 over 4, or 25%. The complement of an event is the probability of the event not occurring, and is found by 1 minus the probability of the event occurring. For example, if we know that the probability of selecting member A from the 5-member list is 0.2, then the complement is 1 minus 0.2, which equals 0.8. Now let's discuss types of events. Independent events are 2 or more events such that the outcome of one event has no effect on the other events. This rule is known as multiplication law of probability. For example, one woman becoming pregnant does not affect another woman getting or not pregnant. Also, when we have 2 or more independent events, we can calculate the chances of both events by multiplying the chances of each event. So let's find the probability of getting the same number 3 consecutive times at random. For example, 2, 2, 2. Let's say that each number is an independent event. Therefore, the probability of getting a 2 is 1 over 10 equals 0.1, and the probability of getting the same number 3 consecutive times will be 1 over 10 times 1 over 10 times 1 over 10, which equals 1 over 1000. Mutually exclusive or disjoint events are 2 or more events that cannot occur at the same time. For example, a person cannot have a normal blood pressure reading and a high blood pressure reading at the same time. Here are some rules and properties of probability. Rule of addition. The probability of event A or event B is equal to the probability of event A plus the probability of event B minus the probability of both events A and B occurring. If events A and B cannot happen at the same time, or as we discussed, A and B are mutually exclusive, then there's no intersection, so the probability of events A or B is equal to the probability of A plus the probability of B. Let's say that we know of 2 doctors, A and B, who test all patients coming into a clinic for a sexually transmitted disease or STD. Dr. A makes a positive diagnosis to 15% of all patients, and Dr. B makes a positive diagnosis to 20% of all patients. Both doctors diagnose 12% of all patients as positive. Each patient with a positive diagnosis is referred to further lab tests. So what is the probability that a patient will be referred for a further lab test if either Dr. A or B makes a positive diagnosis? To answer this question, we will use the rule of addition, where we will add the probability of Dr. A plus the probability of Dr. B minus the probability of both doctors making a positive diagnosis. The result is 0.15 plus 0.20 minus 0.12 equals to 0.23, so 23% of all patients will be referred for further lab tests. Conditional probability is used when we want to compute the probability of two events occurring simultaneously when the events are dependent. The conditional probability of event B given event A is equal to the probability of both events and B occurring divided by the probability of event A. What is the conditional probability that Dr. B makes a positive diagnosis of STD given that Dr. A makes a positive diagnosis assuming that both events are dependent? So our result will be 0.12 divided by 0.15, which equals 0.8 or 80%. General rule for multiplication. For dependent events, we can rearrange the conditional probability rule that tells us that the probability of events A and B occurring is the probability of event A times the conditional probability of event B given event A. The total probability rule indicates that the probability of an event can be calculated using the known probabilities of distinct events. It determines the unconditional probability of an event in terms of probabilities conditional on different scenarios. If there are more events, then the probability can be written as a weighted average of the conditional probabilities of B given A. Therefore, the probability of event B will be the sum of two factors: the probability of B given A times the probability of A, and the probability of B given the complement of A times the probability of the complement of A. Bayes' theorem combines the general rule of multiplication and the total probability rule to obtain the probability of event A given event B. The Bayes rule has many applications, one of which pertains to population-based disease screening tests. For example, on some occasions, only sensitivities and specificities are available, and we need to compute the predicted value of screening tests.